Hi there. Today we're going to move on to looking about transformations of graphs of functions. There are 6 different transformations that we will do in higher mathematics. And it doesn't really matter what the function itself is. What matters is what we do to it. And it will always be clear from any questions you're given whether you're asked to move the graph up or down, left or right, or stretch it or flip it. So we're going to go through all different 6 transformations in separate videos here. The first one that we're going to look at, you can see from the grid of graphs that you have, it's the exact same function that we have here with the exact same points, and we're just going to transform these. What I think you should really do is use 2 different colours of pencils just to highlight which graph is which. Now, when we go to sketch transformations of functions, I always think the best thing to do is to write out the coordinates that you're given first of all. So here we have minus 6, 0, minus 2, 4, 0, 0, 2 minus 2, and 4, 0. I also find it's best to list the coordinates and then from there actually go ahead and identify what those coordinates will look like whenever we transform them. So I've picked out these coordinates here. In red, I'm going to sketch the graph of f of x plus 2. So this here is a graph of y equals f of x. What you'll find is if we ever have a graph of a function, if we have an addition of a number at the end of it or a subtraction, then that means that if this number here, the a value in terms of the graph, if that number is bigger than 0, then we move the graph vertically upwards that many spaces. If the value at the end is less than 0, then we move the graph down that many spaces. So what we have here is a function that goes through minus 6, 0, minus 2, 4, 0, 0, 2 minus 2, and 4, 0. So before we even start to think about what this looks like, let's look at the coordinates. So in red, I'm going to identify the coordinates for f of x plus 2. So when you move coordinates up the way, it's going to affect the y values. So minus 6, 0 is going to move up, and it's going to become minus 6, 2, because it's been moved up 2 places. Minus 2, 4 is going to move up, and that's going to be minus 2, 6. 0, 0 moves up and becomes 0, 2. 2 minus 2 moves up and becomes 2, 0. 4, 0 moves up and becomes 4, 2. So these points we can now plot on the graph. Notice how I haven't changed the x values because the x value is the one that moves along the way. This graph is just moving vertically, it's moving up and down. So that's always going to affect the y values. And a rule that I'll talk about a lot for this topic is if the number is on the outside of the bracket, then it's going to affect the y values only. And when I talk about the bracket, I'm talking about the f of x. More on that when we get to the next graph. So for this, minus 6, 2 is going to be approximately here. Minus 2, 6 is going to be approximately here. 0, 2 would be here. 2, 0 would be here. And 4, 2 would be here. And then all we do is use the same shape of graph. We sketch out. Now, what you'll learn when I do these, my graph drawing skills are not the best, but thankfully you don't have to be a great artist to do this, as long as your coordinates make sense. And when we do this, we must always write down what our transformed coordinates are. So this here was -6, 2. This was -2, 6. This became 0, 2. This became 2, 0. And this bit here became 4, 2. It is vitally important that when you transform your graph, you show where every single point on the graph that you're given has moved to. That is part of the marks that you will get. If you don't show the points, then you will not get the marks. We will always allow a little bit of leeway in terms of graph drawing skills. As long as you're not showing me something like 4, 2 as being up here, when it really should be down across from 0, 2 and -6, 2, then we do allow you to have a little bit of leeway. But always try and stick to the scales that you're given and try and make the graph look as similar to the original as possible in terms of moving the graph up and down. Next, we're going to take a wee look at sketching the graph of y is equal to f of x minus 2. So I'm going to do this in blue. So let me go back to my original coordinates. So on the same way, -6, 0 would go down 2 places and would become -6, -2. -2, 4 goes to -2, 2. 0, 0 goes to 0, -2. 2 -2 goes to 2, 0. And 4, 0 will go to 4, -2. And we plot those points again. So -6, -2 would be approximately here. -2, -2, sorry, -2, 2 I should say, is going to be approximately here. 0, -2 would be here. 2, 0 would be here. No. Sorry, that should be 2 -4, I should have said. 2 -4 should be here. Apologies about that. And 4 -2 would be here. Just make sure you do the correct change. Let me just change that for you on this. So then just sketch out the graph. So a good teaching point here. Yeah, I made a slight mistake and I only noticed it when I was going to sketch the graph. Make sure your graph makes sense. So when I looked at that, I saw 2, 0. That doesn't correspond to moving the black graph down the way to become the blue graph. So always have a think and just take your time. There's no rush with this. And make sure your coordinates make sense. So this was -6, -2. This is -2, 2. This is 0, -2. This is 2, -4. And this is 4, -2. So the first transformation was talking about sketching graphs of f of x plus a. So we had f of x, and we used f of x plus 2 and f of x minus 2 to demonstrate what that looks like. So f of x plus 2, I've moved it up 2 places. F of x minus 2, I've moved it down 2 places.